Assalamualaikum warahmatullahi wabarakatuh and a very good day. Our project is about medical insurance cost prediction using supervised machine learning. Here are the team members: Akim Zakwan, Ku Zenzian, Faris Danish, and also me, Ahmad Mirza. So, for the problem statement and objectives, the main problem addressed in this project is the limitation of traditional insurance pricing models. Conventional approaches tend to assume linear relationships between variables, which leads to inaccurate predictions, especially for high risk individuals. For example, medical costs do not increase linearly when factors like age, BMI, and smoking interact with each other. Therefore, our project aims to achieve three key objectives. First, we aim to predict individual medical insurance costs using supervised machine learning regression techniques. Second, we compare multiple models to identify which algorithm performs best in terms of accuracy and reliability. Finally, we deploy the best performing model into a graphical user interface, allowing non-technical users to generate cost predictions easily in real time. Okay, for the dataset and feature, to train and evaluate our models, we use the medical insurance cost dataset, which contains 1,338 records of individual insurance beneficiaries. The dataset includes several demographic and health related features such as age, gender, body mass index, number of children, smoking status, and also residential region. The target variable is the medical insurance charge, which is measured in US dollars. One important observation from the dataset is the significant variation in costs caused by lifestyle factors.
Next, we will talk about exploratory data analysis. First we can see the distribution of medical charge right school. So we can know the majority of a policyholder have low medical costs. However, a significant tail of high risk outlier will show up. So this make standard linear models may struggle with this extreme value. Next, can see the charge by smoker status. In the box plot, we can see almost no overlap in the cost between the smoker and non-smoker. So for the non-smoker, they have median cost around 7,300. For the smoker, their median cost around 34,000, which is a nearly 400% increase compared to the non-smoker. So smokers show much higher volatility in pricing, indicating other risk factors are play in that group. Next, you can see the BMI versus charge and scatterplot. We color the smoker and smoker in the plot. So we can see uh, BMI impact heavily on the smoking status. So you can see if a smoker they have a non-linear relationship is in the graph. So for non-smoker, they will gradually increase as BMI rise. So for the BMI, it's increase the non-smoker, the cost will increase also linearly. So for the smoker, less than BMI 30 with a normal, they have moderate cost. So for the more than 30 with obese status, so the cost will increase steeply to the 35K or 60K range. So next we see the correlation matrix. We can see the smoker status high correlation 0.79 with a stronger positive correlation with the charge. So we can see the smoker is more contributing to our models. So for the edge, the correlation 0.30, so it's moderate. So this is logic because the head risk increase naturally within the edge. So for the BMI, it appear weak globally, but it's highly significant when interacting with the smoking. So we like we see in the last slide. Yeah, this one. So we will next move the methodology and preprocessing. So we utilize a ML pipeline creates the methodology to ensure the structure life cycle from the business understanding to deployment. So you can see the flow is like shown in the right diagram. So what preprocessing step we use before we training? So we check the no missing value, and we use one hot encoding to the categorize features like sex and smoker. And also we use a standard scaling for the normalization numerical value like age, BMI, children to the normalized value with the median 0 as the standard deviation 1. So last we do the data splitting. We split the data set to the 80% as a training set and 20% as a testing set. This is matter because we want to ensure the fair model comparison because they use same data, same preprocessing step, and we can prevent the bias and data leakage. That's all for me. Thank you.
Now we move on to model selection. So we have chosen 4 kind of model, which is linear regression, decision tree regressor, random forest regressor, and gradient boosting. For the evaluation metric, we evaluate in terms of R2 score, mean absolute error MAE, and root mean square error RSME. Next is the result and performance comparison. So inside this table, we can see that random forests consistently outperform other models in terms of R2 score, which is the highest, 86%. For the MAE and RMSE, it has the lowest score. So, next is for the residual error and model reliability. So after we select a random forest regressor as our model, we have performed a critical analysis. The prediction for 50k and lesser are highly accurate, which is clustered on the red line here. So for the error variance increase as medical costs rise, the model struggles with rare expenses cases. For example, the outliers on the left shows under prediction, predicted at 5k US dollar versus actual is around 25k here. So in summary, while our model is excellent for 80% of population, we still recommend human review for any predicted premium over 30,000 to mitigate high value error.
So now let's talk about what our model learned. The most important factor in predicting insurance costs is smoker status. It has the biggest impact on the price, much more than any other features. After that, BMI and age are the next most important factors. And on the other hand, sex do not affect the cost very much because of this. We focus on the important features to keep the model simple and efficient. Since this model is used for financial purposes, we also made we also make sure the predictions are easy to understand and transparent, which is important to trust and regulations. For deployment, we built a Streamlit web application and we test several models, and random forests give us the best and most stable results. The interface is simple and user-friendly, allowing users to enter details and get a cost prediction instantly. In the future, we plan to add more health information and use tools like Sharp SHAP to better explain why specific prediction is made. Now, let's see the medical insurance cost predicted in action with two examples. First, this is a 25-year-old, BMI 25, one child, and he smokes. When I click the predict button, like here, the estimated cost is about $18,000. Even though he is young, smoking increases the cost a lot. Now we have a 44-year-old female. Let me change. 44 female. Two children. Her BMI might be 28, and she does not smoke. When I click the prediction cost, it costs around 11,000, which is lower despite her age. It shows that our model considers lifestyle choices like smoking are more important than age alone. So that's all from us. Thank you. Bye bye.